Hi, I'm Mohammed Arshad, and the topic I decided to cover for my project is called Reducing Exposure. As you all know, the current outbreak of the novel coronavirus, also known as COVID-19, was declared as a public health emergency by the World Health Organization, where over 6.5 million people have been affected by the disease, with over 380,000 deaths till date. Current stats show as of 3rd of June 2020, the total number of coronavirus cases in Victoria alone is 1,670, which shows how serious of a problem it is. As a population, there are a few ways we can help decrease the spread of this disease. We shall be focusing on two of these strategies for my project today. The first strategy involves hand hygiene, using sanitizers recommended by the World Health Organization formula. The next strategy is temperature screening. Although not as accurate as other modes of measurement, temporal temperature checks prove to be a good screening technique to detect one of the early symptoms of COVID-19. Hand hygiene is already in practice in most of Australia. However, this practice is not supervised and does not guarantee that every individual does this step. However, my system aims to ensure that every individual complies with this step in order to enter the public place, wherever the project is being implemented. Furthermore, temperature checks are manually done by staff being physically present and using temporal infrared scanners in Victoria. The components I shall be using for my prototype are the hardwares are particle argon, Raspberry Pi, ultrasonic sensor, temperature sensor, about 3 to 5 LEDs, DuPont jumper wires, a breadboard, and a micro servo motor. The softwares are Particle IDE, the Raspberry Pi IDE, ThinkSpeak, and IFTTT. I may also use MQTT for transmission for communication between my two devices. This is a visual overview of my prototype. So the system is triggered once the ultrasonic sensor detects the customer's hands below the dispenser. Sanitizer is released onto their hands. While the customer disinfects, they also require to have their temporal temperature checked by the temperature sensor. This data is then recorded and sent to the argon and is then relayed to if this then that. So if the temperature of the customer is below 37.5 degrees Celsius, they may proceed. But if their temperature is above 37.5 degrees Celsius, then appropriate staff is notified and the doors are disabled from opening. The data is then sent to my Raspberry Pi, and that does the final check to confirm if temperature is within the normal range. If it is so, then it commands the servo motor to open the doors. It will command the servo motor to turn, which will depict how a door would open or close. This is the summary of my project. And finally, I would like to discuss some of the possible gaps and solutions in my project. Firstly, being the not very common but possible power failure, which a solution could just be to use a power bank or a generator. Secondly is hardware malfunction, especially in the prototype that we are using. We are using budgeted sensors and hardware. So a solution would be to use higher quality sensors, higher quality equipment, and that would decrease the chances of hardware malfunction. And then lastly, the traffic caused during peak hours as each individual must go through this disinfecting process. This problem is inevitable and hence the only solution is for everyone to adapt given our current situation. And with that, we come to the end of my pitch. Thank you, and I hope you liked it.